Thank you for joining us for this informative American Institute of Chemical Engineers webinar sponsored by Providence Consulting, Realizing the Benefits of a Truly Integrated PHA Process. Our speaker is Nestor Paraliticci. Nestor Paraliticci is a senior PHA facilitator at Providence Consulting. He has over 10 years of experience in the oil and gas industry, along with over 10 years in the safety and health industry. With a focus in PHA, LOPA facilitation and training, he also provides process safety management services, including process safety compliance, incident investigation, and project management. One quick note before I turn the session over to Nestor Paraliticci. As described more fully on this slide, the American Institute of Chemical Engineers assumes no legal liability or responsibility for the use or misuse of the content in this webinar. And now I'd like to welcome Nestor Paraliticci. Hi, Nestor.
Hi, good afternoon, everyone. I'd like to thank Pamela and the American Institute of Chemical Engineers for allowing me to present and participate in these webinars. So let's go ahead and get started. All right. In today's presentation, I'll be giving a brief overview of what a PHA is, and the important discussions and the importance of a good PHA team and having leadership buy-in. This discussion is going to be geared more to those individuals who may not have a lot of experience in PHAs. Then I'll be talking a little bit about conducting PHAs on projects and the importance and the value of doing these PHAs on projects. Then I'll get into the integration of PHAs into the MOC process. What is that, and what does that look like as an end product? And lastly, I'll touch on the overall benefits of these integrating these processes into one system. A while back, I read a quote from Machiavelli that said, "All courses of action are risky. So prudence is not in avoiding danger, that's impossible, but calculating the risks and acting decisively." The environment that we work in on a daily basis is usually dangerous. We cannot get rid of most of the danger, so we try to make sure we understand what the risks are, and then we try to work as safely as possible with these risks in these environments. And that is the spirit of process hazard analysis. Now, OSHA defines a PHA as a thorough, early, systematic approach for identifying, evaluating, and controlling the hazards of a process involving highly hazardous chemicals. But what does that mean? What does a good PHA cover? Keep in mind, this is not an all-inclusive list, but some of the things that PHA would cover are hazards in the process. For example, what happens when there is a pump seal leak? What happens when there's vessel overpressures? And what kind of exposures do personnel have to toxic chemicals? Other things that it covers are consequences of engineering controls or administrative controls that are out there. You have a flow controller at the bottom of a tower and it malfunctions open. Would you have a gas blow-by? And what consequences can you have downstream of the equipment? What happens if you have a level controller and the suction drum to your compressors? Do you have liquid carryover? What does that do to your compressor? Both of these scenarios can lead to personal injury, equipment damage, and business interruption. Another thing that a PHA could cover, quality. It's a qualitative evaluation of the possible safety and health effects on failures of controls of employees. In other words, we're identifying the risks of the systems under review. Okay. Now, a PHA can be used to identify multiple scenarios that might be possible for a process that could result in injuries to people, environmental impact, property loss, business interruption. And in doing so, the PHA helps to provide information which can be used to make decisions in improving safety, reducing risk in processes, and at times help with budgeting, ensuring funds are properly allocated, or even if doing a project PHA as a project is cost effective. We'll talk a little bit more about that during the discussion on project PHAs. So what's the process of a project, of a PHA? First, we discuss the cause. Cause could be anything in your process that could lead to a hazard. Okay? And typically in a PHA, we discuss all credible causes. Now, once we talk or identify what the cause is, we start talking about consequences. Consequences of concern, we want to try to identify these, whether it's a safety, environmental, or business interruption. These are all can be considered consequences. What we want to do with these consequences is try to mitigate them once they're identified. And the way we mitigate those consequences is by identifying safeguards. These safeguards try to mitigate or prevent the scenario from happening. And if we identify sufficient safeguards that are appropriate and adequate for the consequence that we're concerned about, then we get to an acceptable risk. Okay. If there aren't any acceptable safeguards or the safeguards are not adequate, we go into making recommendations. These recommendations try to control and mitigate the hazards that we've discussed or identified afterwards. Try to make sure that these are acceptable risks. Now, what types of PHAs are there out there? Well, there's several that you can choose from. There's what-if checklist. This is your basic structure brainstorming activity, basic simple PHA that can be conducted on early stages of design or simple processes that use a list of predetermined questions to try to determine what the hazards are. Then there's a HAZOP, hazard operability analysis. It's a more structured and systematic examination of the process that you're trying to review. This is a more extensive, as it analyzes the specific causes on almost like a valve-by-valve failure. Okay. Nowadays, this is one of the more acceptable hazard reviews that are out there in current practice. Okay. And this particular HAZOP can be used for just about any kind of process, complex processes, project PHAs. It's really well suited for analyzing complex and simple processes. The next type of analysis is a LOPE analysis. This stands for Layer of Protection Analysis, and this is more of a semi-quantitative risk analysis which uses order of magnitude calculations to measure the adequacy of protection layers. Basically, are your safeguards adequate? Okay. It helps ensure that your target mitigated event likelihood, and each company would develop, identify what their risk tolerance is, and we would aim for that number, again, based on the performance of your safeguards. Another use for this method is to help determine required safety integrity levels of your safety systems. Okay. Basically, any evaluation that you use, okay, to analyze the hazards in your process, okay, can be considered a process hazard analysis. Okay. And we will talk about this a little bit later, but during your MOC process, when you're doing your hazard review checklist, that is actually considered a process hazard analysis. Now, I want to talk a little bit about what makes some items that make an effective PHA. And one of the big requirements here that can affect your quality of your PHA is your team makeup. Okay? OSHA requires that a team have a person with expertise in engineering and process operations, basically your process engineer. It also requires at least one team member who has experience and knowledge specific to the process being evaluated. That's your operator or operations rep. And lastly, one team member of the team must be knowledgeable in the methodology being used, basically your facilitator. So in essence, they just require a minimum of 3 people in the room. So is that enough? Okay. All right. One of the things that we see that improves the quality of the team and the quality of the PHA are inviting other experts in the disciplines, your subject matter experts, rotating equipment engineers, instrumentation engineers, mechanical engineers. That does a couple of things to your process. It adds validity to your scenarios. It makes your existing team a little bit more confident in what the results are, and it leads to better results, whether it's better recommendations or better analysis of identifying these hazards. Okay, and for an MOC meeting, you typically have these team experts or these subject equipment experts in the room already. So when you're doing an MOC, think about having a PHA conducted or a more robust evaluation conducted at that same time. Saves time. Okay. Other factors that could affect your PHA are the years of experience of these personnel. At times we have seen that we have very young engineers, maybe a year or two out of college. They may not have seen or experienced the amount of situations that we talk in a team, and that could lead to delays in the PHA. That could lead to not having the confidence in the quality of the PHA because they might not have the experience to share it. Okay. Another thing that would affect the PHA team, quality of the team, are personalities. Okay. You at times have shy team members that may not speak up and may not question or participate in the process, which again can delay, can affect the quality. Other times you have team members or A-type personalities that can overtake or take control of the conversations and not allow other people to contribute to this conversation. One of the things that we try to do when we have a PHA team and we look at these personalities is ensure that we have a good balance. If we have a young project engineer, maybe bring a more experienced engineer in, kind of to sit in and to help and aid this new process engineer identifies these scenarios. We can also bring in or ensure that the personalities of the team members are balanced throughout by bringing in other process experts or subject material experts that can counterbalance the A-type personality so that they can have, I guess, more of a rebuttal to any kind of conversations that may be overtaken by certain team members. Okay. Another aspect, important aspect of having a quality PHA is the leadership buy-in. And when I say leadership buy-in, I want to focus on more of the area management, and not the refinery management or the facility management, more of the area management, because they're the ones that are going to be presenting and at times defending any recommendations that come out of this PHA. If they are not on board with those recommendations, it could end up affecting the quality of the PHA. We want to make sure that they understand the recommendations that come out of there. Make the recommendations clear, concise, specific, and they got to ensure that they mitigate or prevent the risk that we have identified during these hazard reviews. Okay. One of the ways we can help with this leadership buy-in is to ensure that throughout the meeting or the PHA that the supervisor or the area manager or the team leads are present, maybe not throughout the whole PHA, but maybe once a week, spending an hour going over reviewing the recommendations that have come out through that study so far. That way they can ask questions on the recommendation, how they got there and why they used it and why they think it's beneficial, why it's still fresh in everybody's mind. Another way we can get this leadership buy-in is to have a meeting at the end of the PHA and not only invite the area management, but also invite the personnel or the departments that are responsible for completing this PHA action items. Okay? They can then, again, ask the questions and get the responses back from the PHA team as to why they need it or why they think the scenario is more hazardous than others. That way they can start understanding what the recommendations are, so that when the refinery or the facility management team starts asking them about these recommendations, they can feel comfortable defending them, or at least explaining what the reasoning was from the PHA team to the management team, and help ease that transition of getting these recommendations passed and approved. You know, if the leadership doesn't buy into these PHA recommendations, it could lead to morale issues with the PHA team. You know, why did we spend all this time in the PHA if management isn't going to approve, it doesn't understand these things? It could lead to ineffective safety program. What we're trying to do here is to ensure that we have a safe facility, and we want to make sure that these recommendations are taken to heart so that they're followed and completed. Okay. Next, I want to talk about conducting PHAs on projects. Okay. Why should we conduct PHAs on projects? Well, the first and one of the most important points is to try to identify hazards and mitigation plans in the early stage of design, so that they can be resolved before the process is put into operations. Okay? We help prevent injuries that way. We help prevent shutdowns or startup delays that way. You know, there have been plenty of times during when we have these project PHAs that there weren't certain hazards that weren't accounted for because maybe the initial MOC review, they didn't have the right people in the room to identify these hazards. Okay? We want to make sure that we also, when we do these project PHAs, when we have these subject matter experts in the room, that the design is being looked at by different points of view, so that if there's any risks, okay, within the design of the project, it can be identified at that stage. Okay? With a multiple discipline PHA team, you know, we make sure that everybody has input into what the design is. We can also screen out potential costly system modifications. If we're reviewing a project PHA and we identify that initially they needed or they wanted to put a system shutdown with multiple transmitters, and it'll shut down compressors and pumps, but as we're reviewing this, we realize that the risk doesn't back up that hazard. Well, there might be other things that we can go into. Instead of a shutdown, we can go through alarm systems. We can look into other methods of prevention and mitigation of those hazards that weren't initially identified. Okay. And lastly, a project PHA, going through a project PHA can help with budgeting and revenue allocation for that project. Again, it can help identify areas that are needed or not needed. So it might, at the early stages, it can give you a good idea as to, yes, all these safety systems that we have identified or want to put into the project, they're valid, they are needed. Or the reverse, they may not be needed. We might be able to solve the issue with something smaller or less expensive. Another outcome could be that there are times when they go through the project PHA and they realize that this project is going to cost us initially $10,000, but at the end of the PHA, because of all the hazards identified and the instrumentation and the safeguards that need to be put in, could cost $500,000. So it might give a good indication of the value, whether or not it's cost effective to perform that project. Okay. So a couple of good tips on how to get a good PHA and why a good PHA team is needed, plus getting in a leadership buy-in to lead to a good quality PHA. But then what do we do with that now? Okay. So we get into the 14 elements of the good PSM program. OSHA requires these 14 elements to be part of any facility PSM program. And as you can see on there, PHA and MOCs number 3 and number 10 are listed as parts of the program. The PHA and MOC are critical parts of the standards as they both try to identify the hazards and the risks to the process. And between both of these elements, they touch most of the other elements in the system. Both MOCs and PHA require employee participation, element number 1. PSI is both used and could be affected by the outcome of a PHA and or MOC. Same thing could be said about operating procedures, emergency response, and training. So if these two elements are integrated, there is a potential to improve the other elements of the PSM program. So a little bit about what an MOC is. Okay. The standard says an MOC program contains written procedures to manage change to a covered process. Okay. Now, what does that mean? Well, is there a technical basis for the proposed change? How does that impact the safety and health of the people? Modifications to operating procedures, the necessary time periods for the change, and then obviously the authorization to get these changes made. Okay. Talking about changes to the process must be evaluated to assess their impact on safety and health. Well, that is basically the PHA, process hazard analysis. Now, any MOC program out there should have a hazard review checklist, hazard evaluation, where an MOC team comes in and starts evaluating the process. That in itself is a PHA. Now, the question is that after that evaluation, is a more robust PHA needed? Okay. And then the last part of the MOC process is if there are any changes to the process, the MOC helps ensure that these changes are updated in the PSI, operated procedures and trainings like we discussed before, the other elements of the 14 elements of the PSM program. Okay. Now what you see in front of you is a part of the guidance flow diagram from the CCPS on MOC process. Okay. As you can see here, it goes from identifying change to preparing a request for change form to ensuring that does the change need to be pursued? Is it an MOC change? Okay. And then going through the review process. Now, I did not include the second half of this, which is once the review is done, you go into completing the tasks that have been identified, ensuring that these changes have been made, and then all the documentation that go on with that. But what I wanted to focus on, or give an example, is how we can start integrating PHAs into the system, into this flow. Okay. Now, there's two things we have as a PHA. One is documentation. Old PHAs, previous PHAs, we can start inserting these into the MOC process so that we can start reviewing them before we even get to trying to decide whether or not this is an MOC change. And the other part is actually performing the PHA. Down towards the lower right-hand corner, when we're starting, whether it's a multidisciplinary review or an individual, review, okay, both of these things can lead to, again, the initial hazardous review is a PHA, but then it could lead to, when it triggers it, to more robust hazard analysis. Now, how do we integrate this? So the next couple of slides, we're going to be talking about reviewing past PHAs, the documentation side of it. Okay. Start asking about what is being changed and what kind of triggers we're going to be looking at. Okay. Getting your PHA department involved, and then obviously conducting your PHAs. Okay. Ensuring we have the right method, using the right methodology for each change. Now, going into reviewing past PHAs, well, how is that important? Well, we want to make sure that if you're a process engineer starting a new design or looking into a change, you can go into and get your previous PHA for that unit, and you can start looking at what some of the hazards were, what some of the hazards identified to begin with before you start making any changes. And that way you can have a good idea as to what some of the hazards that you may have to mitigate. Okay. Also lets you look at the process as a whole and see if whatever changes that you are doing are affecting any safeguards. One of the outcomes of a good PHA is having a good safeguard list. That safeguard list are those instrumentation items or PSVs or operation procedures that are used to mitigate those hazards. So if your process or your project is going to affect those safeguards, then we need to start thinking about, okay, we may need to have a more robust PHA so that we can find alternatives to the safeguards that are going to be affected. Okay. And reviewing through those old PHAs or those previous PHAs may give you some more ammunition or some ammunition to back up the changes that you're going to do. I mean, if your changes are going to make the system that was that had a lot of hazards identified a little bit safer, that's a better. It gives you more backup. Okay. You know, looking through this PHAs, it could also, if you look at previous recommendations, you might be able to resolve a previous recommendation by what your project is. Okay. So once you start or getting the idea that you want to do a change to the process, you look back at the PHA and you say, okay, yes, we're going to go ahead and proceed with this project. Okay. You're going to go into start your MOC. And then you're going to go in, gather your team together, and you're going to start asking, well, as a team, what's being changed? Are these changes affecting the process? Are we going to reroute stuff? Are we going to add new equipment? Okay. Are we going to affect any safeguards? Okay. Are we going to demo equipment? Any of these things would trigger a more robust PHA. Okay. And that's why it's so important to have the proper subject matter experts in these MOC hazard reviews. Okay. If you have these subject matter experts in these MOC initial hazard reviews, okay, and you identify that, yes, we're going to need a more robust PHA, well, you already have a team there. You might consider doing a PHA, a more robust, whether it's a HAZOP or what-if checklist, right there at that time. You don't have to come back and reconvene and rehash everything over. The team has already started to get into that mindset of what you're doing, what you're trying to do. Now you're trying to resolve some issues that you may, or identify some hazards that may be part of this process. Okay. Get your PHA department or subject matter experts involved early. Okay. They're the ones that can help you or give you a good idea as to whether or not you're going to need a more robust PHA. Okay. they'll be able to look at your design and say, you know what, this is something that we're going to need more than just a hazard review checklist. We're going to need to HAZOP this, or this is the reasons why we need to HAZOP this. So you can start keeping that in mind as you move along the MOC process. Okay. So once you decide that we're going to need a more robust system, okay, we want to make sure that we help identify these hazards prior to the start of the equipment. We want to make sure that we go in there and see what needs to be done so that we don't go start up the unit and something happens. We have seen operational delays because something was missed, okay, or something was operating unsafe, they had to shut it down, or simply the design just didn't work, okay, because a proper review wasn't done. Okay. Having these reviews with the proper subject matter experts in that room, okay, again, will help ensure that, you know, one design is looked through multiple eyes, points of views. Okay. This will help catch design risks, hazards early on in the design stage so that they can be handled or at least mitigated before they're actually put out in the field. Okay. Another benefit of having affected departments or multiple discipline people in the room is that it gives everybody the ability to speak up and say if it works or doesn't work. We have seen many a times where a project may affect 80% in one region and 20% of another region, and because most of the work is going to be done in one area, only those folks are invited. And then prior to startup, somebody from the other region says, hey, wait a second, okay, we never heard about this. We never talked about this. That can create a lot of conflict in between departments, can create bad morale, and we want to try to avoid that so that we can have, one, a good process, and two, a safe operator, safe system out there. Okay. And again, coming back to that budgeting or cost benefit of the project, looking at and analyzing the system and identifying hazards and design flaws or risks, it helps really look at where do we need to spend the money? How do we need to spend the money? You know, is this a benefit to do? Okay. Okay. And oftentimes, like I stated before, a HAZOP is one of the most logical and detailed ways to assess the impact on the employees in the process, which is what one of the major factors of the MOC process is trying to mitigate those, see what they are, and mitigate them. So, what does a fully integrated PHA MOC system look like? All right. If we start integrating these PHAs into the MOC process and start documenting these things together, we can have, in the perfect world, an electronic version of these things so that we don't have to have, after a PHA, typically it used to be where we do a PHA and you put it in a binder and then you put it in a closet somewhere and it's never touched again until the next 5-year cycle. Now, it's part of the process. We want to go in there and take a look at that. We want to go ahead and get these things so that it is reviewed, constantly updated, and useful during this process. Okay. Part of this integration is getting these internal checks and balances within the MOC program to trigger these more robust PHAs. So as part of the MOC program, you would have a hazard review checklist. And in there, you can have questions on what's changing. Do we affect safeguards? Are we changing the process? And if any of those things trigger, then we can go ahead and start looking at a more robust system that we need to do what-if checklist, HAZOPs, whatever it is, to try to help mitigate those hazards. Okay. Another benefit of integrating the PHA process into the MOC process is the MOC program helps document changes and keeps track of changes in the process. Typically, a process is, by standard, is supposed to be PHA'd every 5 years. That's a long time. And if there's a lot of changes and if you wait until your next 5-year cycle, that can add time to the process, to the HAZOP process or the PHA process that you're doing in that cycle. With keeping these documents, doing these little mini project PHAs throughout the life of the cycle, you can keep that system updated. You can keep the PSI updated. You can keep the hazards identified and mitigated in that cycle. The objective here is to ensure that this is one process. This is not considered or looked at as two different processes. I have an MOC process and it triggers, okay, now I got to stop and do a PHA process. No, we want to consider this one continuous process so that we are continually getting to a place where it's seamless. You go from a design stage. You go into looking at the hazards, analyzing those hazards and mitigating them all in one sequence, so there's no break in there. So combining these systems together gives you a more robust system for identifying and mitigating these hazards. It's just not good enough to identify these hazards. We need to mitigate them. And the MOC process helps in that. At times when we do a PHA, you go through the process, you identify the hazards, you get those recommendations, and then what? What happens to those recommendations? With integrating that into the MOC process, we can have some accountability there. We can identify or put those into the process, and as part of the PSSR process is ensure that these safety items or environmental items are completed before that MOC is closed, before that process is started. Again, one of the other benefits, as I just mentioned, is to ensure that this process is kept current. Is so that if anybody at any time during that 5-year PHA cycle decides, let's take a look at this process and what's happening to it, it's a current picture. If you wait for a 5-year cycle, a lot of changes could happen, as we mentioned before. So doing this as these changes occur, you can see the cycle of this process evolving. And you can also see the interrelations between one project and the next if two different groups are doing projects. Make sure that the system is kept current. And obviously, some of the side benefits is that it helps in the reduction of injuries and incidences. If we identify these hazards and properly mitigate them, there will be a reduction in incidences and injuries, making the facility safer. Integrating these processes together ensures that you have a good employee participation. I mean, that's something that can't be measured, but if you have a good PHA team, a good MOC team, and these subject matter experts talk to each other and they communicate, these teams are going to come out knowing that, hey, I'm happy with the process. I know that we're doing a good job. I know that we're doing creating a safe environment for me to work in. It just improves employee morale. Employees know that management cares because they're resolving these issues and identifying before they become an issue. It's a side benefit that is unmeasurable, but it is a benefit. George S. Patton once said, the time to take counsel of your fears is before you make an important battle decision. That's a time to listen to every fear you can imagine. When you have collected all the facts and fears and major decision, turn off all your fears and go ahead. Again, another perfect example of what a PHA is. You know, we get together, talk about the hazards and issues that we have, and ensure that we try to mitigate them, prevent them, or redesign the process so that we can ensure that every time we go into a facility that we know that we've done everything to make it safe for us to work in and our employees to work in. Okay. Again, I'd like to thank you all for you taking the time to listen to me, to be part of this webinar, and thank you very much. I think we're going to go into our question and answer period now.
Okay, thanks, Nestor. We have a lot of questions. If anyone else has more or another one, please send it to host in the chat box. First one, what is the recommended practice for when to revalidate a PHA for a greenfield site? How long after the plant is operational do you validate the original PHAs?
Okay. Well, the time starts when the process is in full operation. And the major bulk of the process fluids are going through the process. Okay? Once that's established, normal operating conditions, then the time starts. And then it should be 5 years from that time, within 5 years of that time.
Okay, thank you. How is PHA related with SIL rating?
PHAs, you can do, for example, a LOPA. LOPA is, again, a semi-quantitative examination of it, puts numbers to the scenarios. So, for example, it will give you a initiating cause with a certain frequency. Okay, it will then give you the consequence, and you start looking at the safeguards. And the safeguards, you can start identifying certain probability of failure and demand on those safeguards. Those are basically what happens is you're figuring out or the frequency of failure of those items. Okay? And what you're trying to do is to match the company's target of how often these requirements are, or how often these scenarios can happen. And based on your initiating event, how frequent that happens, you add all the failures of your safety devices together, and that number should come up, match or exceed the target event. So, for example, if a certain consequence severity company decides it should only happen once in 10,000 years, okay, you have an initiating event that's 1 in 10 years. You have a couple of safeguards that have a failure rate of 1 in 10 years each. Okay. You come up with, so based on the initiating event and your safeguards, the likelihood of that happening is 1 in 1,000 years, you're short. Okay. Once you figure out that you're short, okay, then you have a gap. And that gap is it's called the LOPA gap. That LOPA gap that you have there, and then you can have whatever order of magnitude. In our example, it's 1 order of magnitude. Okay, if we have 1 more layer of protection, 1 more safeguard, okay, we can meet that expected target of the event happening. So if we have 1 layer missing, gap, then there's several options you can do. You can try to redesign to get rid of the hazard, the risk. You can have administrative programs in place, okay? Or you can have instrumentation. Okay? Now, if you have instrumentation, your SIL, your safety integrated levels, okay, it will let you know that if you're going into that mode of putting instrumentation in, okay, I have to have a SIL rating of at least 1. Okay. The LOPA, or this type of analysis, a PHA analysis, helps identify what level that instrumentation needs to be.
Okay, thank you. What methods have you found successful to communicate the results of PHAs to affected personnel? One
of the better methods is having an overview, a brief, short description of what the PHA was, what was analyzed, what some of the major recommendations coming out of it was, okay, who the team members were, and just kind of give a brief overview, sending that out, okay, to all your affected employees. Not only your in-house employees, but also your contractors. Anybody who works in that area, you can send that out. I think that short overview, more people are apt to reading that than actually a 300-page PHA document.
Okay, thank you. Is there any IT solution that approaches MOC and PHA as one process?
There are software programs out there that do that, but it's more, again, it's integrating that into it. We do have programs out there that are EMOC programs that give you the MOC process, and within that process has those triggers that would trigger the PHA. It would help individuals as they're going through the MOC process ask those particular questions.
Okay, thank you. Is there a good example of a hazard review checklist, or do you have recommendations on how to create your own?
Yeah, if anybody has any, typically what I would do is look at the process that we're being evaluated, and you know, we can formalize it or specifically make that checklist appropriate for that process or that technology. There's a lot of checklists out there. It's just a matter of trying to ensure that it covers the specific process that is being evaluated.
Okay. How do actions tracking register relate to MOC procedures?
Well, part of the MOC process, one of the questions at the end of an MOC process during your PSSR should be, have action items identified during a review, have they been completed? Now, there's two types of action items. There's pre-startup and post-startup. The pre-startup action items are typically those high-risk or safety environmental concerns that we want to try to alleviate before the process starts up. Those, you can have an MOC process where you trigger that and it won't let you go past that PSSR step before those items are completed. Okay,
okay, thank you. Oh, go ahead.
Sorry, go ahead. Whatever program or process that you're using to track these action items, they can be tracked back or documented back into the MOC system.
Okay, thanks. What are the advantages and disadvantages between the bow tie method and other hazard assessments? When would you recommend the bow tie method be used?
There are different. If you're looking at a specific hazard or a specific risk, individual risk, I think a bow tie would be accurate. Would be a better method of analysis. If you're looking at a system, I think some of the lesser or not so robust systems will be more appropriate. It's also a function of your resources. You know, if you go down to what-if checklist or a HAZOP, you typically have a lower requirement for those types of analysis than you would for a bow tie. A matter of, you know, trying to decide, you know, what's more cost-effective. You know, the more detailed the analysis, the more it's going to cost. So it just all depends, I think, on what you're analyzing. Is it a step? Is it one part of the process? I think, you know, as you go more detailed or more specific in your analysis, then you can go into some of those higher processes.
Okay, thank you. When conducting a PHA, should you include the safeguards or conduct it as if there are no safeguards?
You got to do both. Part of the process is one, you know, the first step is figuring out what your cause is. The second step is figuring out what your consequence is. Once you figure out what your consequence is, the consequence should be determined without these safeguards. Okay? So you guys can imagine that the safeguards don't work. Okay? That's how you figure out your consequence. Because that way, when you start listing your safeguards, you can determine based on the safeguards that you have listed, okay, whether or not they're adequate or sufficient to cover that true consequence without those safeguards in place. So you have to do both.
Okay, thanks. What is HAZOP and the role in the process?
I'm sorry, can you repeat that question again?
It says, what is HAZOP and the role in the process?
HAZOP is a hazards operability analysis. I'm sorry, I just don't think I understand what the question is asking.
Okay, whoever wrote in that question, if you could send in a clarification, we'll go on to the next one. Any further guidance on when to elevate from what if to HAZOP, or to LOPA when doing the MOC hazards review?
I think one of the things is the time of whatever that project is. So if you're in your initial first stage, you know, you're running your block flow diagram design of your process, a HAZOP is not conducive for that kind of study, for that kind of process. A what-if checklist is better. Okay. If you have some more of that detailed, you know, specific valves, the pump sizes, the vessel MEWPs, if you have that technical information ready developed, then you can go into your HAZOP. Okay. Now, whether you're doing a what-if checklist or if you're doing a HAZOP, I think the next stage, the LOPA part, has to do a lot with your severity. If you start identifying a lot of high-risk items, okay, I think then you should go into that LOPA and start analyzing some of those high-risk situations using that more robust system. Okay. So I think a lot of what decisions you have to make has to be based on the severity of the outcome of those first analysis, and then you can go into your LOPA. We have there are companies out there that do it all at once, just to, you know, basically kind of close the loop on the system. They identify, they decide, okay, if anything is higher than X severity, we're going to go ahead and LOPA that because we know those are high risks to ensure that we have the proper coverage.
Okay, thank you. One attendee asked if you had any recommendations for young graduates trying to get involved in the process safety industry, but not sure where to begin.
There's a lot of good training programs out there that or classes out there that they can take. They can definitely ask if some of their more senior engineers. They can definitely contact me or to discuss you know, specifics of how, you know, where to go from here. It's just it's getting into the field. I mean, if you have an interest, I mean, you don't even have to be specifically into the PSM field. You just have to have an interest in making your process, whatever you're working on, safe. You know, you start there. From there on, you can take classes, you can take courses, you can talk to senior engineers about the process, the safety process, but making sure that you know, you just have that drive there to make your system safe.
Okay, thank you. How do you effectively discuss human factors within a PHA?
We have, again, we have checklists, human factors checklists. We got facility siting checklists, and you know, we try to tailor those checklists to the process. Again, we want to make sure that we're asked appropriate questions to ensure that some of these items are covered. Again, also depending on the time of the process. You know, again, if you're in the early stages, you know, block flow diagram stage, it might not be worth talking about human factors and facility siting at this point, because it's, you know, it's just a concept right now. But for more organized or established processes, we have a checklist. We go through certain items. We talk about, you know, the control room. We talked about accessibility for maintenance or operation. We talk about the, you know, how has the area been designed as far as, you know, can we have access to it? Do emergency vehicles have access to it? Do we maintain certain processes in place? Do we have the right operating procedures? Do we have the right emergency procedures? We can tailor those human factors specific to that process to ensure that the main topics are covered and properly analyzed if need be.
While maintaining HAZOP actions tracking register, do we need another MOC procedures?
I'm sorry, repeat one more time.
While maintaining HAZOP actions tracking register, would we need other MOC procedures?
No, I don't think you would need another procedure, MOC procedure. You have one procedure that incorporates everything. I mean, part of the MOC procedure is one thing that we have done at some sites is we take the recommendations and not only dump them into their tracking software, but also dumping straight into their MOCs, so that as they're going through that the final check or PSSR validation of that MOC, they can actually see what the recommendations were and see if they were completed or not. It doesn't have to be a separate function.
Okay, thanks very much for that answer. I'm sorry, but that's all the time we have for questions. So if your question was not answered today, please send it to producer@aiche.org. And now, on behalf of the American Institute of Chemical Engineers and all who attended today, I'd like to thank Nestor Paraliticci for this informative presentation. Thanks also to our participants for your cooperation and thoughtful questions. Please visit aiche.org to replay this webinar or to view and sign up for our many others. Goodbye, and we hope to see you again in a webinar soon.